Welcome and thank you for joining tonight. This is a quiet space where science slows down, where numbers and distances soften into gentle stories, and where curiosity becomes a bridge that carries you toward rest. Here, complex ideas about the universe are not a test to pass, but a calm landscape to drift through at the end of a long day. Whether you are already lying down in the dark or still finishing the last small rituals of the evening, this moment belongs only to you. Maybe the room is already dim with only a faint light behind a curtain or the distant glow of a city outside your window. Maybe there are still traces of the day moving through your mind, unfinished thoughts, echoes of conversations, a few quiet worries that have not yet dissolved. All of that can stay in the background now like a fading sound at the edge of hearing. Tonight the journey moves outward into the true scale of the cosmos, into the distances that make everyday numbers feel tiny and strange. It asks a simple question with enormous consequences. What does it really mean for the universe to be so large that even the speed of light is not fast enough to make it feel small? How does it change the way you see your own life when a single beam of light moving at the fastest speed allowed by nature would still need years, centuries, and millennia to cross the gaps between the stars? Before that journey begins, this is a gentle invitation to slow down. If you wish, you can let your eyes grow heavy, let your shoulders drop a little, and feel the weight of the day slide away behind you. You can follow the rhythm of your breath as it moves in through the nose and out through the mouth, a slow tidal motion that rises and falls without effort again and again. With each exhale, the outside world can grow softer and more distant, as if the walls of the room are opening into a wider, darker sky. In that sky, the solar system waits, and beyond it, the galaxy, and beyond that, the vast web of the observable universe. For the rest of the night, you are free to let your mind drift among those scales, while your body sinks deeper into rest. Now the room is quiet, the breathing is steady, and the story can begin its long, slow journey outward. In a quiet room where the lights have already faded to a soft and distant glow, a single listener lies still while the universe continues its vast and indifferent motion beyond the walls. Breathing slows, thoughts begin to stretch and lengthen, and somewhere above the ceiling and the clouds and the thin cold air, the first stars of the story are already burning. The scene is simple and small, a body resting on a bed, yet around that small body unfolds a structure so enormous that ordinary language bends under its weight. In one direction lies the memory of the day just lived with its brief errands, passing worries and short journeys from one place to another. In the other direction lies an expanse of space and time that reaches far beyond the span of any life, beyond the rise and fall of cities, and the entire record of human history. As the body settles, attention turns gently outward, not with urgency, but with the calm of a window slowly opening to the night. Outside, invisible to resting eyes, the planet continues its rotation, carrying continents, oceans, and sleeping cities into the shadowed side of its orbit. The familiar world shrinks to the size of a single point on the surface of a sphere, and then even smaller, a thought drifting inside a mind that is itself made of ancient atoms. Those atoms once belonged to stars that lived and died long before any living eye ever looked up at a dark sky and wondered what lay beyond. The story of scale begins not with noise, but with silence, with the recognition that the universe surrounds this resting body on all sides across distances that cannot be walked or driven in any ordinary sense. The bed becomes a tiny island in a dark ocean without shore, held in place by gravity. and bathed in a thin river of starlight that has traveled for long ages to arrive at this moment of quiet. The narration follows that starlight backwards past the window, past the clouds, past the shell of the atmosphere where air gives way to vacuum. The room disappears, the city fades, the planet dwindles to a bright marble, hanging in darkness, wrapped in faint bands of weather, turning without hurry around its star. From this imagined vantage, a walk across a room, a drive across a town, even a journey across a continent becomes a movement across a speck on the surface of a tiny world. The resting figure on the bed is barely more than a dust grain on that speck, and yet that dust grain holds a working brain, and that brain carries a map of the universe inside it. Neurons arranged in delicate webs exchange faint pulses of electricity, and with those pulses, they reconstruct distances that no body will ever cross and times that no single life will ever live through. As the narration moves slowly outward, it carries that quiet mind with it not as a passenger in a spacecraft, but as a witness drifting on a stream of description. The mind that once worried about hours and minutes now brushes against measures that swallow those small units without effort. The simple fact that light has a finite speed becomes an anchor for the journey. Light feels instantaneous in the world of daily experience. A room brightens when a switch is pressed, a screen lights, a sunrise seems to fill the sky in a moment. Yet even here there is already a hint that this supposed instant hides a delay, a small but real travel time, as photons move from source to eye. It is only the shortness of the distances that makes that delay impossible to feel. As the scale grows, that hidden delay will lengthen until imagination strains to follow it. The bed does not shift. Gravity holds body and mattress to the spinning planet, and the spinning planet to its wide orbit, and the orbiting planet to the deeper structure of a star system. With each step outward, the sense of size stretches a little further. The day fits inside the room inside the city inside the planet inside the moving pattern of the solar system. With every widening circle, the resting figure grows smaller in proportion, but the mind inside that figure grows larger in its field of view. The heart continues its slow rhythm, the lungs continue their steady work, and above that quiet machinery rises a field of awareness that now reaches from the mattress to the orbit of the moon and the far boundary of the solar system. The story of scale is no longer about a person in a room or even a species on a world. It is about matter that once burned in the hearts of ancient stars and now lies still arranged into a nervous system capable of holding an image of the cosmos. In this first stage of the journey, nothing dramatic occurs. No engines ignite, no alarms sound. There is only breathing, and above that breathing, attention. That attention has begun to detach from the narrow corridor of daily tasks and to drift outward in widening circles carried by the slow unfolding of distances that will soon exceed every inherited sense of proportion. The body remains motionless, but the field of awareness now stands on the threshold between the familiar neighborhood of Earth and the enormous machinery of the solar system, ready to take the next step outward into distance and time. From the threshold between a quiet room and the machinery of the solar system, the next step outward rests first on the nearest companion, the moon. It hangs in darkness at a distance that feels almost intimate on cosmic scales, yet for most of human history it remained unreachable, a cold disk painted on the sky. The gap between Earth and its satellite is about 384,400 kilometers, a number that already stretches beyond ordinary experience. When the first missions left Earth to touch that distant gray surface, each voyage took about 3 days. 3 days of motion through a silent gulf with no air, no cloud, no sound, only thin sunlight and a constant fall through the gravity of two worlds. Yet the moon is not a distant frontier, it is only the first step onto the porch of the planetary home. Beyond that porch waits Mars, the red planet that has lived for decades as the next imagined destination. Mars is called a neighbor, but distance gives a different verdict. Depending on the positions of the two planets in their orbits, the gap between Earth and Mars ranges from tens of millions to hundreds of millions of kilometers. With current propulsion, that gap demands a journey of roughly 6 to 10 months. For most of a year, a small crew or a lonely probe must drift through space carrying its own air, its own water, and its own thin envelope of artificial warmth. The alignment that makes this passage practical appears only every 26 months, like a slow mechanical breath in the clockwork of the solar system. From the vantage of a single human life, 6 or 10 months is a long commitment for a single trip. Seasons pass, lives change, entire stories unfold while a craft crawls along a narrow line between two small worlds. For the solar system, however, this journey is almost nothing, a brief flicker of motion across a tiny segment of an orbit. Mars remains part of the inner court of worlds relatively close to the Sun, inside the same compact neighborhood. When attention moves farther outward toward the giants, distance stretches again, and intuition begins to slip. Jupiter, the largest planet in the solar system, orbits far beyond Mars. A probe heading toward this striped giant with present-day technology spends on the order of 3 years in transit. To translate that span into the language of roads, imagination builds a highway through space. A car traveling at 100 kilometers per hour without rest would need close to a human lifetime to cover the same distance. Generations can rise and fall on Earth in less time than it would take to complete that hypothetical drive from the orbit of Earth to the realm of Jupiter. Farther out, Saturn orbits in a colder, more rarefied zone, its rings catching sunlight in thin, bright lines. Reaching this world with present methods requires roughly 4 years of continuous flight. In the imaginary car, the crossing would demand more than 1,000 years of uninterrupted driving. At this stage, the numbers begin to lose their edges. A mind can repeat the words and stack the years in a mental column, but the total no longer attaches cleanly to lived experience. Saturn still belongs to the familiar system circling the same star as Earth, and yet the time needed to reach it already stretches beyond the frame of an ordinary life. Beyond Saturn, the ice giants Uranus and Neptune extend the pattern. Uranus resides at a distance of billions of kilometers from the Sun. A journey there would consume around a decade with known propulsion. Neptune, farther still, demands roughly a quarter of a century of travel. A human being could be born, grow into adulthood, and watch many personal eras unfold in the time needed for a machine to move from Earth out to that distant frontier and send back a final set of images. All of these voyages from 3 days to many years are confined inside one structure, a single star system anchored by an ordinary yellow star. From the inner rocky worlds to the outer gas and ice giants, the entire arrangement fits within a sphere, perhaps a few tens of billions of kilometers across. On the scale of the wider cosmos, that sphere is less than a mote. Still, for the resting mind, it is already a landscape so large that ordinary intuition begins to fail. Movements that rarely exceed a few thousand kilometers must stretch across spans of millions and billions. The result is a quiet dissonance, a sense that the numbers are understood in language but remain hollow in feeling. As awareness lingers on these distances, something subtle appears beneath the calm. If such long journeys are required just to move between nearby planets circling the same star, what does that imply for the gap between stars themselves? If months are needed to cross from Earth to Mars and years to reach Jupiter or Neptune, what kind of time scale would govern a voyage from one star to the next? The solar system, already large enough to unsettle every inherited sense of scale, begins to look like a tiny, delicate device floating in a far greater sea. At its outer boundary, where sunlight weakens and scattered fragments of ancient ice drift in deep cold, the next step outward waits with distances that will dwarf every figure considered so far. At the fragile edge of the solar system, sunlight thins into a pale presence, and the pull of the sun weakens until it is only slightly stronger than the distant tugs of other stars. Fragments of ice and rock drift in slow, stretched-out paths, remnants of an earlier era when planets were still forming. This region, often imagined as a loose cloud of frozen bodies, marks a soft boundary. Inside it, every planet, moon ring, and wandering comet belongs to one gravitational family. Beyond it, the space between stars begins in earnest, and distances swell into a scale where the word far no longer carries enough weight. From the innermost orbit of scorched rock to the outermost trails of cold debris, the main architecture of the solar system fits into a rough sphere about 12 billion kilometers across. That sphere is immense beside any human journey, yet it can be pictured as a single glowing bead hanging in a darkness that continues without visible end. Around that bead, the nearest other bead, the closest other star, waits at a distance that breaks every habit of thought. That neighbor is a small red star called Proxima Centauri, separated from the Sun by roughly 40 trillion kilometers. The ratio between these distances quietly erases intuition. A structure 12 billion kilometers across seems immense until it is set beside a gap of 40 trillion kilometers. In that comparison, the whole solar system becomes a coin lying on a vast empty plain, and the nearest other coin rests tens of kilometers away. The planets, with all their long orbits and complex histories, move inside an area so small that it nearly vanishes in the larger field of interstellar space. The resting mind, following this comparison, begins to see the solar system as a single detail in a much wider pattern. To understand what this means in terms of motion, attention returns to the speed of light, the built-in limit that shapes every possible journey. Light travels at about 300,000 kilometers per second, a speed so great that it wraps around normal experience and passes beyond it. In 1 second, a beam of light could race around Earth several times. In everyday life, that speed feels instant. The delay between source and eye is too small to feel. Yet at interstellar distances, even this extreme speed becomes heavy and slow. A beam of light leaving the Sun needs more than 4 years to reach Proxima Centauri. Those years are filled with continuous motion at the fastest rate allowed by the laws of physics. During that same span on a small world circling the Sun, a child can grow from an infant into a walking, speaking being. By the time that light arrives at the neighboring star, conditions at its source have already changed. Planets have moved along their orbits, and storms have risen and faded in distant atmospheres. Machines built by human hands move far more slowly, the fastest probes ever launched skimming past planets to borrow extra speed from their gravity, reach velocities of hundreds of thousands of kilometers per hour. That pace is remarkable in the context of a single planet, allowing a craft to cross the distance between Earth and the outer planets in years rather than centuries. In the context of interstellar space, however, even these speeds shrink into near stillness. At such velocities, a journey to Proxima Centauri would require tens of thousands of years. Civilizations could rise and fall while a single craft continues its silent straight line through the dark. To bring this image into sharper focus, attention settles on one specific traveler, the Voyager 1 spacecraft. Launched in the late 1970s, it has spent decades falling outward through the solar system and beyond, carried first by chemical rockets and then by the long, invisible slope of gravitational assists. It is now farther from Earth than any other human artifact, moving through a region where the breath of the sun thins and the material between stars begins. After all those years of steady motion, Voyager 1 has covered only a tiny fraction of the distance to Proxima Centauri. Its progress toward the nearest star is measured not in halves or quarters, but in small fragments of a single percent. From the quiet bed on the turning planet, this situation forms a calm contradiction. On one side, the universe feels open. There is no visible wall between one star and the next, no solid barrier stretched across the void. On the other side, the numbers describe a reality where openness does not mean accessibility. The space between stars is not filled with obstacles. It is filled with absence, with distances so large that normal measures fail. In that emptiness, speed itself becomes the main limitation. With present methods, interstellar travel unfolds on timescales that do not fit inside a human life or even inside the memory span of a single culture. As awareness absorbs this, the sense of scale deepens again. The solar system, once a sprawling domain of planets and comets, now looks like a small room inside a much larger building. Beyond the door of that room stretches a corridor so long that even light requires years to traverse it. The nearest star is a faint lamp at the far end of that hallway, shining steadily, but separated by a distance that does not care about individual journeys or hopes. This is only the first step into the galaxy, where the number of stars and the size of their shared structure will extend this pattern of unreachable vastness far beyond even the interstellar gap just considered. Within the dim space between the Sun and Proxima Centauri, the pattern of a larger structure already takes shape even if it remains invisible to unaided eyes. The two stars do not float alone in a blank void. They are two among hundreds of billions bound together in a single spiral galaxy, a rotating disk of stars, gas, and dust called the Milky Way. From the surface of the small planet where the resting body lies, this galaxy appears only as a pale band across the night sky, a narrow river of faint light. Astronomers estimate that the Milky Way holds hundreds of billions of stars. Each one is its own sun, many surrounded by planetary systems. Each system an arrangement of worlds and moons and debris. The sun is one ordinary point among them, a single lantern on an immense, slowly turning wheel. The disk of this galaxy spreads across a diameter of about 100,000 light years. A light year is the distance that light travels in 1 year, moving constantly at about 300,000 kilometers per second. The earlier journey from the Sun to Proxima Centauri requires a little more than 4 years of such travel. Crossing the full width of the Milky Way at that same unbroken pace would take around 100,000 years. This span leaves both individual lives and familiar markers of history behind. 100,000 years reaches back before agriculture, before towns, before written language. It reaches into an era when early humans share the planet with other hominin species, when tools are simple and stories exist only as spoken words by fires that leave no record. Inside this disk, the Sun occupies a modest orbit about halfway between the center and the outer edge. It circles the galactic core at a distance of roughly 26,000 light years. To complete a single rotation around the center of the Milky Way, the Sun requires on the order of 200 million years. During one such galactic year, continents drift, mountains rise and wear down, oceans open and close, and branches of life appear and disappear. Within this frame, the achievements of a technological species on one small planet occupy only a narrow strip of time near the present. The first simple stone tools appear a few million years ago. The first written records arise only a few thousand years ago. The era of radio transmissions, spaceflight, and interplanetary probes occupies barely more than a single human lifetime. During all of this, the Sun and its planets continue their slow path through the galaxy, drifting between spiral arms, passing through regions of greater and lesser density, yet always remaining bound by the shared gravity of the larger structure. From the perspective of the resting body, the mind following this narrative now holds multiple layers of motion at once. Earth turns on its axis once every 24 hours. It circles the Sun once every year. The solar system itself orbits the center of the Milky Way over hundreds of millions of years. These motions stack together, forming a quiet dance. The room seems stable, the ground solid, the stars fixed at great distance. Yet at every moment that stillness is actually a state of continuous transit through interplanetary and interstellar space. Across the galaxy, other stars trace their own orbits, each one moving in response to the combined gravity of all the others and of a massive unseen halo. Some stars cluster in dense globes that swarm around the galactic center. Clouds of gas drift and slowly condense, sometimes collapsing to form new stars, sometimes torn apart by radiation and stellar winds. Shock waves from supernova explosions ripple outward, seeding space, with heavy elements that later become the material of planets and living bodies. All of this unfolds in silence. The distances between stars are so great that even violent events fade into quiet when considered from far away. A supernova that briefly outshines an entire galaxy still leaves most of the disk unchanged. Stars continue their orbits, and the overall structure persists, dynamic in detail, yet stable in its broad pattern over immense spans of time. Within this immense system, the activities of a single species on one rocky world do not alter the motion of stars or the form of spiral arms. Even the most powerful rockets developed so far barely lift a few tons of metal and instruments out of the gravity well of Earth. 5 spacecraft slip beyond the outer boundary of the solar system and enter interstellar space, their radio signals spreading outward as faint expanding spheres. Compared to the scale of the galaxy, these actions resemble small ripples on the surface of a vast ocean, yet those ripples carry something new. Inside them, encoded in patterns of radio waves and in the hardware of the spacecraft, resides knowledge. That knowledge describes the galaxy that the species cannot physically cross. It maps the positions of pulsars and records the spectra of stars. Through these records, a small pocket of matter in one corner of the galaxy comes to understand the larger system it inhabits. The Milky Way does not notice yet in a quiet way the galaxy is now aware of itself through the minds that have arisen within one of its many star systems. The journey of scale thus progresses from local distances to the architecture of a whole galaxy, and still the path ahead leads outward toward an even wider pattern of countless galaxies spread across expanding space. Beyond the slow-turning disk of the Milky Way, another pattern emerges made not of single stars, but of entire galaxies gathered into families. The Milky Way does not drift alone. It belongs to a small association called the Local Group, a loose collection of more than 50 galaxies bound together by their shared gravity. At the heart of this group, two giant spirals face one another across the Milky Way and the Andromeda Galaxy. Around them swarm smaller companions, dwarf galaxies in irregular fragments like islands scattered around two larger continents. Andromeda lies at a distance of about 2,500,000 light-years. The light that leaves its billions of stars must travel for 2.5 million years before it reaches the small planet where the resting body lies. During that time, ice ages come and go, species appear and vanish, and entire human civilizations rise, flourish, and fall, all while a single beam of light makes its silent journey across the gap. When a telescope on Earth captures an image of Andromeda, it records not the galaxy as it is, but as it was when early hominins first took cautious steps on ancient landscapes. In the local group, gravity slowly pulls the two large spirals toward one another. Over billions of years, their mutual attraction will draw them into a long, complex dance of approach, distortion, and eventual merger. Stars will not collide directly. The distances between them are too great. Instead, the overall patterns of dust, gas, and stellar orbits will shift, forming new structures out of the overlapping disks. In a future far beyond the scale of human history, a single larger galaxy will exist where two once stood. In this slow process, the local group offers a first glimpse of a larger architecture. Galaxies are not evenly spread like grains of sand. They gather in groups and clusters bound together on scales where the combined gravity of many galaxies shapes their motion. Several nearby groups, including the local group, fall into a larger structure called a supercluster. Within this broader region, space behaves like a slow, three-dimensional river of matter where galaxies drift along paths carved by the gravity of all surrounding mass. Wrapped through these forms is something more difficult to see, an invisible framework of unseen matter that exerts gravitational influence without emitting light. This hidden web guides the gathering of gas and the birth of galaxies. The visible structures follow lines and nodes in this web, forming a pattern that resembles a vast cosmic network. When astronomers map the positions of galaxies on very large scales, the universe appears as a kind of foam or lattice with bright threads and dense knots separated by immense voids. In those voids where galaxies are rare or absent, space stretches almost empty for hundreds of millions of light years. From the perspective of a single star system, these distances are nearly impossible to internalize. A light year already exceeds every measure used in daily life. 1,000,000 light years stretches beyond the full history of the human species. Hundreds of millions of light years reach back toward the earliest eras of galaxies themselves. Yet the cosmic web spans billions of light years from one side of the observable universe to the other. At these scales, even the Milky Way and Andromeda together become only a small bright knot in a thin filament of matter. Underlying this vast arrangement is an unexpected behavior of space itself. On local scales, gravity binds matter together. Planets remain in orbit around stars, stars remain gathered into galaxies, and galaxies remain associated in groups and clusters. On the largest scales, however, observations show that space is not static, it stretches. The distances between far-flung galaxies increase over time, not because those galaxies are flying through pre-existing space, but because the fabric of space itself is expanding. Light traveling across this expanding domain experiences a quiet effect. As it moves, the space it crosses stretches and the light is lengthened to redder wavelengths. Distant galaxies appear not only faint but shifted toward the red end of the spectrum. The farther away a galaxy lies, the more pronounced this effect becomes, indicating that it has been moving away for longer, carried outward by the expansion of space. Within the local group, gravity wins. The mutual attraction of the Milky Way, Andromeda, and their companions is strong enough to resist the general expansion. But beyond a certain scale, the stretching of space dominates. Galaxy groups and clusters recede from one another, their separations increasing over billions of years. The observable universe thus presents two contrasting behaviors, at once local gathering and global dispersal. In one view, matter falls inward, forming stars, galaxies, clusters, and filaments. In another view, the frame that holds all of these structures grows larger and larger, the distances between far-separated regions increasing without limit. For the quiet mind following this description, the effect is layered. First comes the recognition that planets and stars inhabit vast spaces. Then comes the realization that galaxies are themselves scattered like islands in an even larger sea. Finally, there is the understanding that this sea is not fixed. It is swelling, changing the distances between islands over time. The local group drifts as a small raft on a rising tide of space. The next step in the journey will follow that tide outward toward the faint edge of what can be seen and measured into a realm where some galaxies are already slipping beyond reach forever. From the great lattice of galaxies and voids, attention turns toward the limits of sight themselves. The universe, as traced by telescopes and detectors, does not extend indefinitely in any practical observational sense. It appears instead as a finite bubble of visibility, a sphere within which light has had time to travel since the first moments after the beginning of cosmic expansion. Beyond that sphere, there may be more galaxies, more clusters, more stretches of filament and void, but their light has not yet arrived. The observable universe is therefore not a boundary of existence, but a boundary of contact set by the distance that light can cross in the lifetime of the cosmos so far. The age of the universe is currently estimated at about 13,800,000,000 years. During that time, light has been moving ceaselessly through expanding space, carrying information from distant events toward any region where it might eventually be detected. It would be tempting to assume that the radius of the observable universe should match this age when expressed in light years, as though 1 year of time automatically produced 1 light year of reach. The real situation is more subtle. While light travels, space itself stretches. Galaxies that emitted light billions of years ago are at the present moment much farther away than the simple product of speed and time would suggest. Because of this stretching, the current radius of the observable universe is roughly 46 billion light years, and its diameter is near 92 or 93 billion light years. These values do not contradict the cosmic age. They reflect the fact that space has grown while the light was in transit. This turns deep space into a quiet time machine. Looking farther outward means looking farther backward. The nearest galaxies show recent chapters of cosmic history. More distant systems reveal earlier epochs when stars are younger and elements heavier than hydrogen and helium are scarce. At the greatest distances accessible to present instruments, faint smudges record some of the first galaxies to condense within the cosmic web. Beyond even these lie relic signals from an earlier era, still the cooled afterglow of the hot, dense phase that later unfolded into the present rich structure. Within this expanding bubble nearby, galaxies move mostly under the influence of their mutual gravity. Members of the local group drift and interact, some approaching, some receding their speeds, modest beside the speed of light. At larger scales, recession dominates. Almost every distant galaxy appears to be moving away, with the recessional speed increasing with distance. This pattern is not the result of a single explosion from a central point. Rather, it reflects a nearly uniform stretching of space, like a rising loaf of bread, in which raisins move apart as the dough expands. Each raisin sees the others receding and experiences itself as centered, even though no special location exists. As distances grow, this recession leads to a quiet but striking consequence. For galaxies far enough away, the rate at which space expands between them and a chosen point exceeds the speed of light. No law of physics is broken. The galaxies are not racing through space faster than light. Instead, space itself is increasing in scale, carrying them apart. Light emitted from those far systems may never reach the observers who receive photons from nearer sources. In effect, there exists a cosmic event horizon, a surface beyond which events can never affect a given region, no matter how long time advances. The position of this horizon is not fixed. As the universe ages and the expansion continues, more and more galaxies cross from the visible region into permanent invisibility. Their light, already red, shifted by the stretching of space, grows fainter and longer in wavelength until it slips beyond the sensitivity of any practical detector. After that point, those galaxies still exist, still form stars, still participate in the evolution of the cosmic web, but for the small pocket of space they have left behind, they have effectively vanished. The map of the observable universe slowly simplifies as distant features are erased by expansion. In the far future, according to current models of cosmic acceleration, the view from a typical star system will be different from the view available in the present era. The local group and any groups bound in similar fashion elsewhere will remain intact, still held together by their own gravity, while everything beyond those local structures recedes beyond the event horizon. Future astronomers in those isolated islands of matter may see only a single merged galaxy or a small cluster of companions surrounded by darkness that appears endless on every side. This introduces a quiet and unexpected feature of the present moment in cosmic time. The universe is not only vast, it also occupies a particular stage in its history when much of that vastness is still visible. Enough time has passed for light from remote galaxies to arrive, but not so much time that expansion has carried them irretrievably beyond contact. The current cosmic epoch is a kind of observational window, a brief interval on cosmological scales during which the large-scale structure of the universe can be measured directly. On the small planet where one technological species now rests and listens to the story of distance, this circumstance adds another layer to the sense of scale. The resting body on the bed, the galaxy that contains that bed, and the entire observable universe are all sharing a particular slice of cosmic time, a fleeting stage in which knowledge about the whole can unfold before the view slowly narrows again in epochs still to come. In the layered picture that now fills the quiet mind space has grown from the radius of a single planet to the diameter of the observable universe. Structures now range from small worlds of rock and ice to clusters of galaxies strung along a cosmic web. Yet another axis waits to be traced with equal care, an axis not of distance but of time. Just as intuition falters when confronted with vast space, it bends when asked to hold the full age of the universe beside the briefness of individual lives. The universe, according to current measurements, has been unfolding for about 13,800,000,000 years. In that span, matter cools, gathers, and rearranges itself in successive layers of complexity. For long ages there are no stars, no planets, and no observers, only a hot, dense mixture of particles. As expansion proceeds, this early fire thins until light can move freely, leaving behind a faint background glow that still fills all of space. Much later, gravity draws gas into knots where the first stars ignite. They burn hot and short, forging heavier elements, and then scattering them outward in explosive deaths. Only after many such cycles do later generations of stars and planets emerge with enough heavy material to build rocky worlds, complex chemistry, and eventually biology. Even then, the path from simple molecules to thinking nervous systems is slow and fragile. Against this backdrop, the appearance of a technological species on one small planet is extraordinarily recent. If the entire age of the universe is compressed into a single calendar year, with the beginning at the first instant of January and the present moment at the final breath of December, then the Milky Way forms in late winter. The solar system condenses in early September. The small rocky world that hosts the resting body cools while life takes hold. Single-celled organisms dominate most of this compressed year. Complex multicellular life appears only in the last months. Dinosaurs roam during a span that occupies a few weeks near the end. Modern humans, anatomically similar to those who now build telescopes and probes, arrive in the final evening of December. The entire written history of civilizations, from the earliest symbols pressed into clay to present-day digital records, fits into the last few seconds before midnight. In those final seconds, simple tools give way to metals, sail, and oar, give way to engines, and finally rockets rise through the air to place small machines beyond the atmosphere. A handful of crewed missions reach the orbit of the moon and return. Robotic probes touch down on nearby worlds, fall inward toward the sun, or slip outward past the edge of the solar system. The total physical reach of this species remains tiny beside the size of its home system, vanishing beside the width of the galaxy, and effectively zero when set against the full observable universe. Yet during that same sliver of time, a different kind of reach expands. Through instruments and careful reasoning, this young species reconstructs the history of stars and galaxies, measures the motion of distant systems, and infers the presence of dark components that outweigh familiar matter. It maps the ancient afterglow from the early universe and uses tiny irregularities in its pattern to deduce the seeds of the large-scale structures seen today. In doing so, a particular arrangement of atoms on a small planet becomes aware of events that took place billions of years before the planet itself existed. This contrast between physical reach and conceptual reach gives the present moment its quiet strangeness. Almost all activity remains confined to a thin shell around a single world, a region only a few hundred kilometers thick, compared to the planet's diameter, and only a fraction of a light second across compared to interplanetary distances. At the same time, the maps and equations developed on that world cover distances of billions of light years and timescales that run from fractions of a second after the beginning of cosmic expansion to predictions about the universe billions of years in the future. This asymmetry creates a distinct perspective. From one direction, the universe appears overwhelmingly large and indifferent, its scales dwarfing the efforts and concerns of any single species. From another direction, the presence of beings who can understand those scales even partially adds a new feature to what exists within the universe. Before stars form, there is only hot, expanding plasma. Before galaxies gather, there is only diffuse gas. Before life and consciousness arise, there are no questions, no models, no recognition of patterns. With the arrival of minds, the universe acquires an internal mirror, an ability to reflect on itself through the awareness of structures that emerged inside it. In the quiet room, the resting body remains small and fragile. Heartbeat and breath continue at their slow, familiar pace. Outside, the planet spins, the solar system orbits within the Milky Way, and the galaxy moves through the larger web. None of these motions depend on observers, yet within the brain of one such observer, and in the combined work of many, the layered structure of space and time becomes visible. The universe, vast beyond direct comprehension, now includes at least one corner where that vastness is known at least in outline. This knowledge does not alter the motion of galaxies or slow the expansion of space, but it does quietly transform the experience of existing within that immensity. The journey of scale has revealed how small a single life is beside the cosmos, and at the same time how large the cosmos becomes inside a single life when its story is understood. On the small planet that turns around an ordinary star, almost all activity of the technological species remains pressed against the surface of its world and the thin layer of air above it. Cities climb only a little way into the sky. Aircraft rise a few kilometers, then return. For practical purposes, almost everything that most generations experience takes place within a narrow shell of atmosphere and near space. A different measure of reach comes from the brief history of human voyages beyond that shell. A small number of missions carry crews into orbit. Fewer still push outward toward the moon. During a short span of years in the 20th century, a handful of astronauts ride rockets across the gap between Earth and its satellites, stay for a brief time on the gray surface, then return. In all of human history, only a dozen individuals walk on another world, and that other world lies less than 2 light seconds away. Light that leaves Earth needs about 1 1/3 seconds to reach the moon and another 1 1/3 seconds to return. Robotic explorers carry the story farther. Probes touch down on Mars, fall into the clouds of Jupiter, pass through the rings of Saturn, and skim the atmospheres of distant moons. Others swing past the planets and continue onward, their paths bending as they steal small increments of speed from each gravitational encounter. Among these are 5 craft that have either left or are on the verge of leaving the region dominated by the immediate influence of the Sun. 2 Voyagers, 2 Pioneers, and 1 craft called New Horizons follow elongated trajectories into interstellar space. Voyager 1 travels the farthest. Launched in the late 1970s, it has been moving outward for nearly half a century. It speeds along at tens of thousands of kilometers per hour, faster than any aircraft or crewed spacecraft, and yet the numbers again conceal a deeper scale. After all this time, Voyager 1 has covered a distance measured in tens of billions of kilometers, enough to carry it past the orbits of the outer planets and through the boundary where the solar wind yields to the thin gas between stars. This is an extraordinary accomplishment by any local measure, but when set beside the gap to Proxima Centauri, it shrinks to almost nothing. If the journey from the Sun to the nearest star is imagined as a walk around the Earth along the equator, a path of about 40,000 kilometers, then the distance Voyager 1 has covered so far is comparable to a single step or two. Decades of continuous motion powered first by rockets and then by the simple conservation of momentum have carried it only a tiny fraction of the way. It has left the planetary neighborhood and entered interstellar space, yet it remains close to home on the scale that matters for travel between stars. The comparison can also be drawn in terms of time. If Voyager 1 were aimed precisely toward Proxima Centauri and allowed to continue at its present speed, it would require tens of thousands of years to arrive. During that interval, countless generations would be born and die on Earth. Continents would shift slightly, climates would change, languages would drift, and cultures would appear and disappear. All the while, the small machine would follow its single line through the dark, indifferent to the passage of history behind it. This reality reveals something about the dream of interstellar travel. The universe does not forbid motion between stars, but it sets conditions that make such motion slow and costly under known physics. To cross the gap in timescales comparable to human lives would require speeds close to that of light, and those speeds demand energies that grow steeply with velocity. As an object with mass accelerates, each further increase in speed requires more energy than the last. Near the speed of light, the energy needed grows so great that it becomes impractical with any technology presently understood. Even if such energies were available, new effects would appear. At speeds approaching that of light, time aboard the craft would pass at a different rate than time in the rest frame of the galaxy. From the frame of the travelers, the journey might take a few years or decades. From the frame of the origin world, centuries could pass. Meanwhile, the craft would need to shield itself against stray atoms and dust grains in the interstellar medium. At such high velocities, each tiny impact would deliver energy comparable to a burst of radiation. The engineering challenges accumulate until the vision of a simple starship crossing the gulf in comfort begins to fade. Against the background of these constraints, the current state of exploration gains a particular shape. A small set of machines leave the solar system and drift outward, carrying plaques and records that describe their makers and their home world. Their signals weaken as distance grows, then eventually fall below the threshold of detection, but the craft themselves continue their journeys in silence. They become durable, unconscious ambassadors, each one a moving fragment of a story whose origin lies in the thin shell of life on a single world. The interstellar gulf keeps the horizon of physical travel close, yet within that tight horizon, knowledge has already stretched far beyond the reach of any probe. The next stages of the journey into cosmic scale may therefore unfold less through engines and more through understanding as minds refine their picture of a universe that they can map in detail, even while their bodies remain close to the surface of one small turning world. As the layered image of the universe settles more firmly in the quiet mind, another pattern begins to stand out, one that concerns not only where matter is arranged, but when different structures can be known. The observable universe is not a static picture. It changes with time, not only because galaxies move and stars live and die, but because the reach of light and the rate of cosmic expansion together determine what can ever be seen from any given point. The present era in this respect occupies a narrow band of opportunity. In the early universe, soon after expansion began, matter and radiation were tightly coupled. Space was filled with a nearly uniform hot plasma. Light could not travel far without scattering. There were no galaxies, no stars, and no isolated beams carrying information from one place to another. As the cosmos expanded and cooled, the plasma recombined into neutral atoms and the fog cleared. Light from that moment began to move freely, filling space with a faint glow that persists as the cosmic microwave background. Only much later did gravity gather gas into the first stars and galaxies, adding bright localized sources of light to the diffuse background. During those early ages, an observer, had one existed, would have seen a sky very different from the present one. The large-scale pattern of the cosmic microwave background would have been more intense and at shorter wavelengths. Galaxies would have been fewer, smaller, and more irregular. Many of the structures now familiar, such as well-formed spiral galaxies with rich populations of heavy elements, had not yet emerged. The cosmic web, while present in seed form, had not fully grown into the intricate network now mapped by surveys. In the far future, the sky will change again. The expansion of space is not slowing. Current evidence suggests that it is accelerating, driven by a component often referred to as dark energy. As this acceleration continues, the distances between galaxy groups will increase at an ever faster rate. Light from currently visible systems will stretch to longer and longer wavelengths, dimming steadily. Eventually, many galaxies beyond the local group will cross the cosmic event horizon. After that point, no further signals from them will ever arrive. The record of their existence written in photons will end for any observers remaining on the small planet and its descendants. In that distant epoch, the cosmic microwave background itself will also fade. Its characteristic wavelength will be stretched beyond the sensitivity of practical detectors. The universe will still carry the imprint of its hot origin, but that imprint will no longer be directly measurable. Future astronomers, isolated within a single merged remnant of the local group and surrounded by apparently empty darkness, may find it difficult to infer that other galaxies ever existed, or that space was once filled with a brighter background of relic radiation. Their best models might suggest a cosmos that is smaller, older, or qualitatively different from the one reconstructed in the present era. This temporal asymmetry gives the current moment a quiet significance. For a relatively brief interval on cosmic timescales, the universe is both old enough and still transparent enough for its large-scale history to be observed in multiple independent ways. Galaxies at various distances reveal different stages of structure formation. The cosmic microwave background preserves an image of conditions when the universe was very young. The distribution of galaxies on large scales traces the underlying web of dark matter. When combined, these lines of evidence allow a coherent story to emerge, linking small fluctuations in the early plasma to the vast structures of the present. From the viewpoint of the resting body on the small planet, this situation introduces a subtle form of rarity. The existence of observers requires a certain degree of cosmic maturity. Heavy elements must be synthesized in stars and scattered into space. Planets must form and cool. Life must arise and evolve toward complexity. All of this takes billions of years. Yet if too many billions of years pass, accelerating expansion will remove much of the visible evidence for that earlier history. There is therefore a broad but finite window during which beings capable of reflection can also access a clear view of their universe's past. The idea that such beings appear during this observationally privileged interval may not be an accident. It may reflect a simple selection effect. Observers can only exist when conditions support their emergence. And among those times they find themselves in eras when the clues needed to reconstruct cosmic history remain available. In this sense, the universe does not arrange itself for observation. Instead, regions and periods that allow both life and clear evidence of the past naturally become the only stages where questions can be asked. Within that stage, the technological species on Earth has used its brief window effectively. In just a few centuries of careful study, it has gone from seeing the Milky Way as the entire universe to recognizing that the galaxy is one of many. It has detected the faint afterglow of the hot early cosmos, measured the accelerating expansion, and mapped the cosmic web across billions of light years. These achievements unfold in the final seconds of the metaphorical cosmic year in a thin slice of geological and biological time. Meanwhile, at the level of individual lives, everything remains small and immediate. The resting body lies in darkness. Nearby buildings stand, trees sway, oceans shift under the pull of the moon, and weather systems move across continents. None of these phenomena hint directly at accelerating expansion or ancient background radiation. The daily environment carries no obvious sign that the universe is changing in ways that will eventually erase much of its visible structure. Only through instruments and abstract reasoning does that larger picture become apparent. The result is a layered existence. On the surface, life continues within cycles of days, seasons, and generations. Beneath that, hidden by scale, the universe moves through phases that reshape what can be known. The present moment, with its particular balance of age, transparency, and structure, supports both conscious observers and a rich supply of evidence for them to study. Eventually that supply will thin, and any distant descendants may stare into a darker, emptier-looking sky, unaware that their region of space once shared the cosmos with a far wider company of galaxies. In the layered view that now surrounds the resting body, the universe stretches outward across billions of light years and backward across billions of years. Yet another direction of scale waits beneath the skin. The same matter that participates in galaxies and stars also forms cells, molecules, and atoms. The vastness of the cosmos has a matching depth of smallness, and within that depth the conditions for awareness quietly assemble. A journey inward, traced with the same calm attention that has followed distances outward, reveals another kind of scale that bends intuition. Inside the skull of the resting figure, a brain rests in near darkness, floating in clear fluid supplied by branching networks of blood vessels. Within this organ, tens of billions of nerve cells interconnect in intricate patterns. Each neuron is a tiny structure compared to the size of the body, yet each one can receive and send signals to thousands of others. The total number of connections in this network is thought to reach into the hundreds of trillions, a quantity that rivals the number of stars in a typical galaxy. Electrical impulses travel along these branching fibers, and chemical signals cross the microscopic gaps between cells, all in patterns that remain hidden from conscious experience. This inward scale continues. Neurons are built from smaller structures, from proteins and membranes, from folded chains of atoms that form channels and receptors. These in turn depend on the arrangements of electrons around atomic nuclei, on quantum behaviors that play out in spaces far below direct perception. Within those spaces, probability and uncertainty govern the positions of particles. The familiar solidity of the resting body is revealed as a collective effect arising from countless interactions among constituents that never stand still. The same physics that shapes the evolution of stars also determines the structure of these atoms and molecules. Gravity orders the large-scale architecture of the universe. Electromagnetism and nuclear forces govern the behavior of matter at smaller scales. Together over billions of years, they guide the condensation of gas into stars, the forging of heavy elements, and the creation of planets where chemistry becomes complex. On one such planet, in one thin film of suitable conditions that chemistry crosses a threshold, molecules assemble into self-copying structures. Membranes form enclosing internal processes. Cells arise, then multicellular organisms, then nervous systems capable of integrating signals from many parts of a body. Eventually, on the world beneath the resting body, brains evolve that can form images of their surroundings, anticipate outcomes, and store memories across decades. In some of those brains, a further property appears, a sense of being a continuous field of experience in which sensations, thoughts, and feelings arise and fade. This development adds a new layer to the hierarchy of scales. The universe now contains not only matter and radiation, not only stars and galaxies, but also systems that model their environment and themselves. Within such a system, the distances between stars and the age of the cosmos can become objects of representation. A brain that fits within two hands can hold in abstract form the history of a universe that extends for tens of billions of light years. The contrast is sharp. The size of the brain remains small compared to the body, which in turn is tiny compared to the planet, which is a speck beside the sun, which is a point in the Milky Way, which is a thread in the cosmic web. Yet the range of scales that the brain can represent runs from subatomic particles to the observable universe. In this sense, the inward journey of scale meets the outward journey. The smallest components and the largest structures are joined within a single field of awareness. This joining does not alter the laws of physics, nor does it change the trajectory of galaxies. A neuron continues to fire or remain silent according to its inputs. A star continues to fuse hydrogen into helium in its core. The expansion of space continues at its measured rate. What changes is that some of these processes are now mirrored internally as patterns of activity in a brain. From another angle, this situation introduces a quiet puzzle. The same basic ingredients and laws exist throughout the observable universe, yet the emergence of complex life and consciousness appears to require a convergence of conditions that may be rare, stable stars, planets in suitable orbits, liquid water, long periods without catastrophic events, and evolutionary histories that favor increasing complexity. Whether such convergences occur frequently or only rarely across the cosmos remains unknown. The chain from simple chemistry to reflective awareness involves many steps, each contingent on countless details. In the quiet room, this uncertainty translates into two possibilities. One is that the resting body is one among many conscious beings scattered through the galaxy, and beyond, each arising where conditions allow, and each constructing its own picture of the universe. Another is that conscious life is exceedingly rare, that the appearance of a species capable of understanding cosmic scales is an unusual outcome of a long chain of events. In either case, the fact remains that in at least one location, matter arranged itself into a system that can experience and comprehend. The journey of scale thus reaches a moment where outward and inward extremes meet within a single organism. The same atoms that once drifted as gas between ancient stars now participate in the activity of neurons that hold the concept of those stars in mind. The universe, vast and indifferent in its large-scale behavior, now includes at least one point where it is quietly aware of itself. From this meeting point, between the vast and the minute, the journey of scale begins to curve back toward a single question that threads quietly through every layer described so far. A universe expands, stars are born and die, galaxies gather and drift apart, and in at least one corner of that immensity, a species arises that can chart these processes in detail. The fact of this charting introduces a calm mystery. What role, if any, does awareness play in a cosmos whose large-scale dynamics precede whether minds exist or not? A small temporary body lies in a dark room, and inside its brain unfolds a process that ties together events separated by billions of years and billions of light years. Within that brain, pulses of activity correspond to images of star fields, to timelines of cosmic evolution, to maps of the galaxy and models of expanding space. These internal patterns have no influence on the trajectory of distant clusters, yet they represent those trajectories with notable fidelity. A configuration of neurons that persists for a fraction of a second can encode the idea of a universe that will continue for trillions of years. A brief arrangement of electrical and chemical states inside a human skull can mirror the outline of a reality that would exist even if life had never emerged. At the same time, awareness itself is also a product of the universe. The laws that shape the motion of galaxies also shape the behavior of atoms. In one region, that behavior leads to stars and planets. In a subset of those planets, it leads to complex chemistry and biology. In a smaller subset, it leads to nervous systems and experience. From this perspective, consciousness is not separate from the rest of the cosmos. It is one of its possible states arising when matter is arranged in particular patterns under particular conditions. Observers are portions of the universe examining other portions using tools and methods that are themselves expressions of natural laws. This realization folds the journey of scale back on itself. The galaxies mapped on the largest scales are made of stars that fuse elements in their cores. Those elements are scattered into interstellar space and later incorporated into clouds that condense into new stars and planets. On at least one such planet, some of those elements join to form neurons. Those neurons participate in thought and perception, and those processes produce models of the very galaxies and stars from which their constituent atoms originated. In a calm and literal sense, the universe has developed a capacity to look back at its own history through the eyes and instruments of beings that emerged within it. Whether such self-reflection occurs rarely or frequently across the cosmos remains unknown. Vast volumes of space may pass from early fire to cold expansion without ever hosting systems that are aware of that trajectory. In other regions, awareness may arise wherever conditions allow, giving rise to many pockets of self-reflection, separated by distances so great that they never share information. In all these possibilities, the role of awareness is similar. It does not halt expansion, nor does it alter the arrangement of the cosmic web. Instead, it adds an additional layer to reality. Matter that previously moved and interacted without reference to meaning now participates in systems where patterns are evaluated, models are tested, and questions are posed. The existence of such systems means that in some regions the universe is not only present but also interpreted. There is a record, however local and temporary, of what has happened on scales far beyond the immediate environment. The resting body in this picture is a nexus where many scales intersect. At the level of cells and organs, it embodies evolutionary history on one small planet. At the level of experience, it contains a personal timeline of memories and feelings. At the level of knowledge, it may hold images of galaxies, black holes, and the early universe. The same heart that pumps blood through a branching network of vessels also supports a brain that imagines the structure of space-time. The same lungs that draw in air shaped by local weather patterns also sustain narratives about superclusters and accelerating expansion. This intersection does not resolve into a simple conclusion. The universe remains vast, old, and indifferent in its large-scale behavior. Stars will continue to form and die whether or not they are ever observed. The expansion of space will carry distant galaxies beyond each other's horizons, regardless of whether any civilization notes the event. Yet the presence of awareness means that in at least some places these processes are accompanied by understanding. There is a knowing of the vastness, a recognition of the smallness of individual lives within it, and a quiet astonishment that such knowing is possible at all. As the journey of scale continues, it begins to turn from description toward gentle speculation. The same laws that have led from hot plasma to galaxies and from simple chemistry to reflective minds may allow further stages that are not yet visible. New forms of organization, new modes of awareness, and new ways of relating to the cosmic environment may arise in the long future. For now, the resting body in the dark room exists at one particular point in that unfolding story, carrying within it the capacity to trace the path from the smallest known scales to the largest, and to feel a deep, silent wonder that such a path can be traced at all. As the narrative drifts along this quiet curve of reflection, another dimension of possibility begins to unfold within the already immense framework. The universe in its present form supports a thin scattering of worlds where complex chemistry has run long enough to assemble living systems. On at least one such world, that process has reached a stage where a technological species can observe and model its cosmic environment. From that single confirmed instance, imagination extends cautiously outward, wondering how frequently similar patterns arise elsewhere in the galaxy or beyond. Within the Milky Way alone, planets are abundant. Observations of exoplanetary systems reveal a wide variety of configurations: hot gas giants skimming close to their stars, super-Earths with thick atmospheres, worlds locked in orbits where one side always faces the light, and planets that circle dim red dwarfs in tight loops. Among this diversity, a subset may occupy regions where liquid water can persist on the surface, where temperatures remain within ranges favorable to complex molecules. Around ancient stars, such conditions might have held for billions of years, offering long periods in which life could emerge and evolve. Whether such evolutions regularly culminate in reflective minds and technological civilizations is unknown. The chain from simple self-replicating molecules to nervous systems and self-awareness contains many steps, each vulnerable to interruption. Extinctions, impacts, unstable climates, and other disruptions may halt the process on many worlds. On others, it may continue producing organisms that adapt to local environments in ways that never require advanced technology. Yet even if the probability of a reflective civilization arising on any given habitable planet is small, the sheer number of stars and planets in the galaxy leaves room for the emergence of multiple such species separated by vast distances and times. If and where they arise, these other civilizations face the same physical constraints described earlier. Their worlds circle their stars within narrow orbital bands. Their home systems occupy small regions within the galaxy. The space between stars remains large, with velocities limited by the speed of light and acceleration bounded by practical energy sources. These constraints encourage a similar asymmetry between physical reach and conceptual reach. Local environments can be explored directly, while the broader cosmos can only be studied through observation and inference. In this picture, the galaxy becomes a collection of isolated theaters of awareness. Each one hosts its own history of life, culture, and understanding. Each one constructs models of the surrounding universe using the same underlying physical laws, perhaps expressed in different languages and mathematical forms. The distances between these theaters are so great that direct communication may seldom occur, if at all. Civilizations might rise, flourish, and fall without ever knowing whether others exist. In that case, awareness is widespread, and yet locally solitary, like points of light scattered across a dark landscape without bridges between them. Even this speculative view remains grounded in present knowledge. It does not require faster-than-light travel or departures from known physics. It simply extends the observed pattern of abundant planets and consistent physical laws, then overlays the possibility that evolution sometimes converges on complex minds. Beyond this more daring lines of thought, consider whether future developments in understanding might allow forms of connection or experience not yet foreseen. Perhaps new theories of space-time will reveal subtle channels of correlation at large scales. Perhaps advanced civilizations will discover ways to encode information or experience into structures that persist for cosmological durations, leaving durable traces of their presence embedded in the fabric of the universe. For the resting body on the small planet, these possibilities remain abstractions. Daily life continues within familiar boundaries shaped by local conditions of gravity, climate, and social structures. Yet within that life, a mind can contemplate scenarios in which awareness is a recurrent feature of the cosmos rather than a singular accident. The thought itself alters the way the universe is perceived. Instead of a single lonely theater of reflection, there may be many, each unfolding its own version of the same story of curiosity and discovery. At the same time, the far future of the universe imposes its own quiet limits. Stars will eventually exhaust their fuel. Stellar birth will slow as gas is consumed or locked away. Galaxies will dim, leaving behind fading embers of long-dead systems. Over timescales so long that ordinary language strains to contain them, matter will continue to evolve towards simpler configurations, isolated remnants, sparse gas, and faint background radiation. In such a cosmos, the conditions needed for complex life and active awareness may become rare or impossible. In this combined view, conscious civilizations occupy narrow windows in both space and time. They arise in suitable environments within galaxies during eras when stars still burn and heavy elements remain abundant. They explore, understand, and perhaps alter their local surroundings. They develop stories about their origins and about the structure of the universe. Then, whether through internal causes or external events, they eventually pass away. The universe continues its expansion, carrying forward the traces of their existence as long as those traces can persist. The small resting body lying in the dark room exists within one such window. Its lifetime spans only a tiny fraction of the age of its species, which in turn spans a tiny fraction of the age of its planet, which occupies a small fraction of the age of the galaxy, which itself spans only part of the age of the universe. Yet in that thin band of existence, the capacity to know and to wonder has emerged. Through that capacity, the scales of distance and time that define the cosmos become part of a lived experience, even if only briefly. This does not resolve into an instruction or a moral. The universe does not issue guidance, it simply presents itself in its layered structure from subatomic processes to the cosmic web, from early fire to expanding space. Within that structure, awareness appears as one of many possible patterns. The quiet wonder that arises when that awareness contemplates its own origins and surroundings is itself another phenomenon of the universe, as real in its domain as the motion of galaxies is in theirs. In this sense, the journey of scale circles back to where it began, in a darkened room where a single body rests while the universe continues its vast motion beyond the walls. The same matter that once drifted between distant stars now supports a mind that can follow the story of that matter across billions of years and billions of light years. That mind may fade, and its species may eventually vanish, but for a brief span the universe includes within itself not only distances and times, but also the quiet awareness of those distances and times. Far beyond the present age and far beyond the lifespan of any existing species, the universe continues its slow transformation. The galaxies that now form bright islands in the cosmic web grow older. Their reserves of cold gas, once abundant and ready to condense into new stars, gradually diminish. Star formation, which now proceeds at a steady but declining pace, will one day slow to a faint trickle. The bright blue, short-lived stars that dominate young regions already give way to longer-lived, cooler suns. As time passes, the average color of starlight in the universe shifts toward the red and then toward the infrared, as younger, hotter stars die and are not replaced in equal numbers. Within each galaxy, the stellar population ages. Massive stars live brief, intense lives and end in supernova explosions, leaving behind neutron stars and black holes. Smaller stars persist for billions or even trillions of years, steadily fusing hydrogen into helium at a gentle rate. Around many of these long-lived stars, planets may continue to circle, some still capable of supporting complex chemistry and perhaps life. These quiet systems extend the window during which awareness can arise or persist, even as the overall cosmic environment grows more diffuse. Over longer spans, even these durable stars eventually exhaust their nuclear fuel. White dwarfs cool, radiating their stored heat into space. Neutron stars slowly lose their energy. Black holes swallow matter that wanders too near and emit faint radiation over unimaginable timescales. The brilliant structured universe of luminous galaxies evolves toward a sparser, dimmer state populated mainly by remnants. The night sky, as seen from any surviving world, will change gradually. Constellations will distort as stellar motions accumulate over millions of years. Later, as more stars fade, the sky will grow thinner, its familiar patterns dissolving. In the far future, an observer, if any remain, might see only the closest stars in a sky that once contained thousands of visible points. The Milky Way and Andromeda, long since merged into a single larger system, will stand as an isolated island of matter, surrounded by an expanding darkness in which other galaxies have receded beyond contact. Within this long narrative, the role of conscious civilizations existing or potential becomes a matter of timing and adaptation. Some might arise early under bright young stars in vigorous galaxies. Others might emerge later around faint red dwarfs that burn steadily for trillions of years. Each such civilization would confront the same large-scale facts in different contexts, a universe that once was denser and brighter and will one day be colder and more diffuse, a cosmos whose expansion gradually removes distant regions from view. Advanced beings, if they appear, may attempt to shape their environment to extend favorable conditions. Speculative models imagine civilizations that engineer stars, redirect matter, or build structures on scales that dwarf planets. Such constructs might harvest energy more efficiently, slow local processes to match dwindling resources, or attempt to store information against the long decline of available free energy. Whether such efforts would succeed over truly cosmological times remains unknown. The fundamental direction of entropy suggests that in the very long run, energy gradients that support complex processes will fade. Information stored in matter will be vulnerable to gradual erasure through random fluctuations and slow physical change. Black holes, once perhaps seen as ultimate repositories or engines, will themselves evaporate through quantum processes over spans that exceed the current age of the universe by enormous factors. These projections are rooted in present physics extended into regimes far beyond direct test. New discoveries may alter this picture, revealing phases or mechanisms not yet imagined. Perhaps the universe passes through transitions that change the nature of space-time itself. Perhaps there are cycles, bounces, or branches that allow complexity to arise repeatedly under new conditions. Alternatively, the one observable history may flow steadily from hot, dense origin to cold, diffuse future, without such renewals carrying along within it only a limited interval during which structures like galaxies, stars, planets, and conscious beings can exist. In this speculative landscape, the present epoch stands as a middle chapter. The universe is no longer an opaque plasma. It has long since formed stars and galaxies, synthesized heavy elements, and allowed biology to arise on at least one world. At the same time, it has not yet reached the sparse cooled state predicted for the distant future. Energy sources remain plentiful, matter is richly structured, and the large-scale pattern of the cosmic web is still visible. This is an era in which both complexity and knowledge can flourish. The resting body in the dark room participates in this middle chapter. Its existence depends on a long chain of stellar generations and planetary conditions that have not yet run their course. Its awareness of cosmic history depends on a window of transparency that has not yet closed. The mind that considers the fate of stars and the eventual dimming of galaxies is itself a temporary phenomenon arising during the interval when such events can be both sustained and understood. This awareness does not alter the eventual direction of cosmic evolution, but it does confer a particular character on the present. The universe includes for a time beings who not only inhabit it but also project their thoughts forward into its future, tracing the likely outlines of its long cooling and expansion. In doing so, they extend the journey of scale not only outward and inward, but also forward into eras when no direct observer may remain to witness the final stages. In the quiet darkness of the room, the narrative of the universe has stretched outward to the edge of the observable cosmos and forward into eras when galaxies fade into sparse embers. Now it folds back toward the narrow band of time and space in which the resting body exists. The contrast between scales becomes especially sharp when the history of one species is set beside the age of the universe and the depth of cosmic time. The universe has unfolded for about 13,800,000,000 years. For most of that span, no written records exist. No telescopes, watch the sky, and no mathematical symbols describe the motion of planets. Stars burn, galaxies collide, and supernova explosions scatter heavy elements into space without any accompanying awareness. On the small planet that now hosts a technological society, life appears relatively early in planetary terms, but complex multicellular organisms occupy only the last chapter of its history. Anatomically, modern humans emerge a few 100,000 years ago, a brief moment compared to the age of the planet, which is on the order of 4,500,000,000 years. During most of that time, the species lives in small groups, moves across landscapes on foot and tracks, timed through seasons and lifetimes, rather than through precise measurements. Only in the last few thousand years does writing appear, allowing knowledge to accumulate in ways that persist beyond direct memory. Civilizations rise along rivers in fertile valleys on coasts and plains. They develop agriculture, cities, and trade. They build monuments that reach a few hundred meters into the air and ships that cross oceans. They chart the positions of stars by eye and construct calendars based on the apparent motion of the sun and moon. In this era, the sky is both a practical guide and a source of myth, but the true scale of the cosmos remains hidden. The apparent dome of stars seems close, perhaps a crystal sphere or a distant shell. The Milky Way appears as a luminous band without clear structure. Only in the last few centuries does a new phase begin. Telescopes extend vision, revealing moons around other planets, the rings of Saturn, the complex structure of the Milky Way, and eventually the faint smudges of other galaxies. Careful measurements of variable stars, supernovae, and galactic recession build the case for an expanding universe with a finite age. Spectroscopy reveals the chemical compositions of stars and nebulae, demonstrating that the matter of distant suns and the matter in human bodies are made of the same elements. Particle accelerators probe the behavior of matter at high energies, connecting small-scale physics to conditions in the very early universe. This transformation in understanding occupies a very thin slice of time. If the age of the universe is compressed into one calendar year, the emergence of modern humans occurs late on the evening of the final day. All of recorded history fits into the last few seconds before midnight. The development of modern astrophysics and cosmology occupies less than a blink in that compressed timeline. Yet within that blink, the species manages to reconstruct much of the preceding cosmic year, tracing events back to fractions of a second after the beginning of expansion. The ratio between time known and time lived becomes another striking measure of scale. Individual lives last for decades. Civilizations endure for centuries or occasionally millennia. The universe spans billions of years. Despite this disparity, a single lifetime now suffices to learn the broad outline of cosmic history. A person born into the present era can, within a few decades, acquire knowledge that reaches from quantum scales to galaxy clusters, from the physics of atoms to the dynamics of dark energy. Within the brain that contains this knowledge, patterns of neural activity represent events that took place long before Earth formed and that will continue long after the sun has exhausted its fuel. The resting body in the darkened room is thus both insignificant and comprehensive in different respects. Its physical extent is small, its mass is negligible compared to that of the planet. Its lifespan is brief beside geological and cosmic timescales. At the same time, the awareness arising within it can encompass in conceptual form a range of scales that far exceed its own dimensions. The universe so vast that no single observer can traverse more than a microscopic fraction of it, nonetheless becomes present in outline within the confines of one nervous system. This intersection of smallness and comprehensiveness gives the present moment a distinct flavor. A being whose body occupies a narrow region near the surface of a small world can hold within its mind a model of a universe 93 billion light years across, filled with billions of galaxies, and shaped by laws that operate from the smallest measurable scales to the largest. That model is approximate and incomplete, yet it captures key features with enough accuracy to predict observations and guide exploration. In this way, the universe that exists outside the resting room and beyond the planet becomes mirrored in a quiet interior landscape. The sense of insignificance that arises when comparing a single life to cosmic scales is therefore only part of the picture. The same comparison also reveals an unexpected property of the cosmos. Within its vast, mostly indifferent expanse, structures have emerged that can register and understand that expanse. The matter that once drifted as gas between early stars now participates in thoughts about the evolution of galaxies. The atoms forged in supernova explosions support a brain that can calculate stellar lifetimes and estimate the age of the universe. The journey of scale, having moved outward and inward and forward in time, now rests briefly on this fact. The universe is large, old, and governed by consistent laws. It also contains at least one point where those laws are recognized, where the story of expansion, structure, formation, and eventual cooling is told in a quiet voice to a listener lying in the dark, while distant galaxies continue their slow drift beyond the horizon of sight. The arc of the story now spans from the earliest moments of a hot, dense universe to a present filled with galaxies, stars, planets, and at least one form of reflective life. It has traced distances from the gap between Earth and the Moon to the separation between galaxy clusters and timescales from fractions of a second after cosmic expansion began to projections billions of years into the future. All of these layers converge quietly in a single scene, a darkened room, a resting body, and a mind that holds this narrative in a state poised between waking thought and sleep. Within that mind, the universe exists in miniature as a web of concepts. The Milky Way becomes a remembered spiral, the local group a cluster of points in an internal model, the observable universe, a sphere of light and time extending outward in imagination. These internal images are faint compared to the physical reality they represent, yet they are precise enough to follow. A thought about the speed of light can jump in a moment from the orbit of the moon to the distance of Andromeda, from the travel time of a radio signal to the age of the cosmos. In this way, the mind compresses scales that physical motion can never span in a single lifetime. The gap between what the body can reach and what the mind can understand becomes another quiet feature of the universe. On the one hand, a human body never leaves the narrow band of air pressed to the surface of its world, except for brief excursions into near space. On the other hand, the awareness supported by that body can range across the whole observable cosmos in thought, and even beyond it in speculation. Within seconds, attention can move from the behavior of neurons to the structure of galaxy clusters, from the fate of a single star to the long cooling of the universe. This mobility does not require engines or fuel. It depends only on the dynamics of a biological network built from atoms that once flowed through stars. This small fact carries an understated strangeness. matter that drifted in interstellar clouds, that was compressed into the core of a star, that was fused into heavier elements and scattered in a supernova, now participates in the formation of questions about its own history. The same physical laws that govern the fall of an asteroid or the orbit of a planet now govern the activity of neurons that calculate those orbits and predict those falls. In this sense, the universe is not only a collection of objects and forces, but also a process in which some regions become aware of the whole. Whether such regions are rare anomalies or common outcomes remains unknown, but their existence at all marks a turning point in the story of matter. With awareness, the universe acquires an internal record of itself that is more than a simple physical trace. Stars and galaxies leave marks in the distribution of elements, in the arrangement of structures, and in the background radiation that fills space. Minds leave marks in language, art, mathematics, and memory. These marks can describe not only local conditions, but also the large-scale pattern of the cosmos. They can encode understanding of expansion, structure, formation, and the deep connection between small-scale physics and large-scale evolution for a limited time, as long as civilizations persist. And records endure. The universe thus contains pockets where its own nature is not only expressed but also known. From this vantage, the earlier sense of insignificance acquires a complementary tone. Individual bodies are small and fragile, and their lifetimes are short beside cosmic timescales. Yet the capacity for awareness and understanding that arises within them is not a trivial addition to the universe. It is a new mode of organization, a way in which matter comes to hold a representation of itself. The galaxies and clusters remain vast and indifferent, but in at least one place their existence is accompanied by comprehension and by a quiet, wordless awe. The narrative does not resolve the question of why such awareness exists. It cannot say whether consciousness is inevitable in any large universe, or whether it is a rare and unlikely event. It cannot predict how long reflective species will endure, or what forms of mind might arise in eras to come. It can only set out the facts as they are known: an expanding cosmos, rich structure on many scales, consistent physical laws, and the appearance within those laws of systems that can contemplate them. The scene in the dark room with one resting body and one drifting mind therefore stands as both a small and a profound moment. It is small because it occupies almost no volume and almost no time compared to the cosmos. It is profound because within that moment the universe is not merely there. It is also known, felt, and reflected upon. The story of scale, traced from the smallest constituents to the widest structures, ends not with a conclusion but with an open horizon of questions. How many other minds elsewhere in space and time have followed similar paths of thought? How many will arise in the future under different stars in galaxies that will never be seen from this world? How far can understanding extend before the fading of energy and the expansion of space remove much of the evidence on which it depends? The answers remain beyond reach, but the questions themselves are already part of the universe, held gently in the activity of neurons in a small resting brain, while distant galaxies continue their silent motion through the dark. The room grows quieter as the narrative's edges soften. A body lies still, its breath slow and regular, while above it the planet continues to turn through the shadowed side of its orbit. The vast structures that filled the mind a short while ago begin to blur into simpler impressions. A sense of deep distance, a memory of starlight crossing empty space, an image of a spiral galaxy slowly revolving in darkness. Numbers and precise terms fade. What remains is a broad feeling of a universe that is both immense and calm. Inside, the resting brain activity settles into slower, more regular patterns. Thoughts about galaxies and light years loosen and drift apart like clouds thinning at high altitude. The story of cosmic scales no longer unfolds as a sequence of ideas. It lingers as a gentle awareness that the world outside the walls is part of something far larger, and that this larger pattern continues whether it is being considered or not. The same atoms that carried the narrative now return to quieter tasks, supporting the rhythms of breath and heartbeat as they move through the night. Beyond the room, the familiar motions persist. The solar system traces its path within the Milky Way. The galaxy follows its course through the surrounding web. Light from distant clusters continues to travel across expanding space, carrying news of events that will never be witnessed directly. None of this demands attention. It simply unfolds slowly and steadily under the same laws that govern the motion of air in the room and blood in the veins. As sleep approaches, the boundaries between inner and outer landscapes grow less distinct. The mind that once held detailed images of stars and galaxies now releases them, allowing them to sink below the surface of awareness. What remains is a soft impression of belonging to a larger story, of being composed from the same matter that fills the sky, and of resting for a while within a universe that is vast, ancient, and quietly ongoing. In that recognition, thought becomes lighter, eyelids heavier, and the long journey of the night begins to merge with the longer journey of the cosmos, both unfolding at their own unhurried pace.